Hey, I'm Fiona. I've created a tool called MetaProgramObjects. It lives in the repository python-scaly-tools under the folder Metadata Objects. I created this tool for two reasons. One, to dynamically create the container boxes for classes and objects. And two, to show that the internal workings of Python are around object-oriented program itself. So everything in Python is an object. Previously, I'd written Python PSAP notes. This details a lot of the background knowledge that I had before building this tool. I won't go into the detail of that. So the code, the tool, the metaprogram objects has two main functions. The first one is get metadata objects. So there are two parameters, objects and print attributes. Objects should be supplied as a list. So even if it's one object, put it in a list. And if it's several objects, then also it goes in a list. The print attributes can truncate some of the output. An example given here is the string IBM, and there's some example output. So you can see that it is in it's in a box. So the container box has been created dynamically. It is an object, so it's got the name object here. If it was a class, I've given it the name class. All objects are unnamed, so it's unnamed unless the user specifically manually creates a name for the object, but Python doesn't name objects itself. The class of the object is type string. The memory location is this number here, and the value is IBM, and then the object attributes are listed down here. So these are objects in their own right. They've been sort of embedded with extra information here on this output. So it's separated firstly by where they come from. So this is origination, not lookup. So I've got, quickly look over here at the PSAP notes. So this is a diagram for objects, and if it's an instance of certain classes. So here it shows Chad, the object, and it's instance of these classes and ultimate superclass object. Metaclass type has nothing to do with the creation of object, only for classes. So if I were to superimpose IBM string over Chad, then there'd be no cat classes, but just simply the string class, and then the object type has nothing to do with it. This bit here about object attributes is also helpful for understanding how the output of this dynamic container box has been created. So independent object variables, there are none for this type, this string. From direct class, so that would be the type string. There is a little bit here to say that there are special class attributes which they originate from the metaclass type. Even though the type has nothing to do with the creation of the object, type had something to do with the creation of, well, not something, a big bit to do with the creation of the string class, and it injects these attributes into that. And then there are no user-defined superclasses, and then up to the ultimate superclass object. So back to the output here, that is how this has been constructed. So there are no independent object variables. The first criteria is the class, the direct class string, and it is a special attribute originally put into the type string from the metaclass type. So just highlighted that there. The next set of attributes are directly from the direct class type string, and then finally from the ultimate superclass object. If I look into all of these, so the attribute name column to show, is it a variable or is it a method? The class of the attribute itself. So because everything is an object, everything also has a class of its own right. And then the memory identifier of that object itself. So I put that to show for me all of the different memory locations of these objects, to show that it's not all contained in the container box. The container box is only a metaphor to help visualize the object and what it can reference, but these are physically not located in the same container box. And then simply the value as well. The print attributes, so I could truncate, by turning that to false, I can truncate that so I only get the header part of this. And then the second function, extract all nested objects. This is for iterables. So any kind of list, dictionary, tuple, or set. So here is an example of a dictionary which contains information about IBM. Every single bit of information in here is an object in its own right. So it's a series of nested dictionaries. All the keys are objects, and then all of the values are objects. By turning dictionary keys parameter to false, for my container box, I will omit the dictionary keys. So I will only see the values. So I will see the full dictionary, and then it will skip the IBM key and show the value of the IBM key. And then it will skip rebus, and it will show the value of rebus. And then it will skip key I and show the value I, and so on. I've given lots of different types of objects so that we can see that in the output of the container boxes. So here's a float, here's a date, a lot of strings. There's a tuple if I were not to suppress the output of the keys. There's an integer, and there's a boolean. The quick start helps show how to get started quickly. It's located in the same folder as the metaprogram objects tool. Therefore, the import looks like this. If the code is in a different folder to the metaprogram objects, which is likely, then the folder extensions will need to be added. The examples that are given here are the same as the ones that are given in the README. If I give this a run, hopefully I see lots of container boxes for all of the examples. Perfect, yes, lots of container boxes. One thing that I want to pick out is the value for some of the objects is given like this. This is a hexadecimal value, and it's actually the same as the memory. It's just that the memory is given as an integer. I've got some code here that proves that point. So I've used IBM string as the example, obtained the memory ID, changed it into hexadecimal, turned it back into memory ID, and then asked the question, are they the same? And yes, they are. One final thing I want to show is the foundations for building out this tool. So I used dir as the main piece of this tool. Dir is just a listing which will give all of the attributes for the object that's passed to it. So if I give this a run, I see all the object attributes for IBM. And for me, for a long time, I didn't understand what they all were, and I didn't find it that helpful. So hopefully this tool is a lot more helpful. The main tool, Metaprogram Objects, is here. There is all of the code, and then at the bottom there's some tests inbuilt to run if it is the main module. I like these tests because they are all inbuilt objects into Python itself. I haven't had to write any code except for simply creating a float here and a simple string here. So if I give this a run, hopefully I see objects for all of these container boxes. Yep, so the first one, so now it's a class. Previously we'd looked at the string IBM, which was an object, so it gets class at the top here. It's a class, it has a name, which is object. Object is the ultimate superclass, so there are no superclasses above it, so it doesn't have any. The class that created object is the metaclass type. And then looking into the class attributes of object, these ones here, independent class attributes, are defined in itself, object, and then metaclass type passes over this attribute here. The next container box is for the metaclass type. It is a subclass of object. The class that created type metaclass type is metaclass type itself. And then we have the class attributes for class type. So the independent class attributes, which were created in itself, and then the attributes which are inherited from being a subclass of the ultimate superclass object. The next container box is for another class. It is the class int. Its base class is the ultimate superclass object, and the class that created it is class type. And then these are the class attributes for int. So created in itself, and then metaclass type has passed over the doc, and it has inherited these from ultimate superclass object, and then from both type and ultimate superclass object it has inherited these attributes. Permission error is one that I enjoyed looking at. So its base class is the OS error, and obviously type as well created the permission error class. The reason I like it, when I look into the class attributes, I can see the MRO for all of the classes which are part of the inheritance chain for the permission error. So starting with permission error itself, it creates this attribute. Type gives it this attribute into its independent class attributes, and then type also gives it the dictionary. And then we go into the MRO. So the base class, the OS error, these attributes, and then further up the MRO in the base exception, and then into the ultimate superclass object, and then both object and type. And then we're back into objects. So the bases in the header disappears because objects do not have base classes. They're objects. So yeah, that's the float. IBM string, which we've looked at, and then false, which is a boolean. Interestingly, it inherits from the boolean class, but it also the int is part of the MRO chain as well. And then also an object is the module main. So often see that written, see it here, if underscore name equals underscore main. So these these are the objects which sit inside main. And finally, the built-ins, which is also an object. It's of the class module, and these are the object attributes for that. And finally, having a look here in the demo examples folder for the code metadata demo. Prior to this, have looked at inbuilt features in Python or really simple strings or floats, but now looking more at advanced user code and trying to analyze that. So there are 5 examples here. Each one is showing something slightly different that is beneficial from the tool. So the first one is around the scales and ladders example. Primarily the reason for doing this was because to prove that fact that everything in Python is an object, and to do it recursively to the very top of the tree. Trying to do that for to program it dynamically, recursively, the result, and put the results into like a text document or Excel, the results explode exponentially, and it's really difficult to manage. So I simply kind of controlled it here. So I'm controlling the recursion into each object. So starting here with the class Burmese Python, and then Monty is an object of Burmese Python. And then looking into Monty has a method, last constriction, and then Monty last constriction, the weekday, that's an object, and then the class of the weekday is also an object, and then the class of the weekday class is also an object, and that happens to be type, so that is the end of the recursion in the tree. This example is also good because it has, if I look at it, there are lots of classes in the inheritance ladder defined. So when I run the demo, it's quite good to see in the output. So I can do that now. So I've got it outputting to file here. So first of all, there is the class Burmese Python, and then looking at the object Monty. Because I've not manually named Monty, I'd have to manually give it a name variable called Monty. It doesn't pick it up, so it remains unnamed. But it's quite good to see. So we see the independent object variables of Monty. So they're defined specifically for the object, either in the object constructor of the Burmese Python class, or created on the fly onto the object Monty. And then it's what it has inherited. So from metaclass type, it has injected doc and module. Type, again, not directly, because it's type did it to the Burmese Python class, which then gives it to object Monty, because we're looking at origination. And then Monty's direct class, which is Burmese Python. We see the attributes that it gets from there. And then the direct class of Burmese Python is Python. So there's some more attributes from there. And then the direct class of Python is snake, and then reptile, and finally scales and ladders, and right at the top of the MRO is the ultimate superclass object. Also, when doing this, I noticed some cool things happening with the methods, so I've detailed them out here. The second example was designed specifically to show inheritance and overriding and the diamond shaped problem. So if I look at the artist colors, I specifically put this variable primary color. So it goes into the primary colors, so red, yellow, and blue. And then I'm creating an object reddish brown from the class reddish brown. And that was depicted in the README, the way it works here. So the question is, what will... Oh, it's Autumn Conquer. Not reddish brown. Autumn Conquer. So Autumn Conquer, what will its primary color be? And the answer to that is blue, because the way it's resolved is it goes up the tree first of all, so it hits a green and red at the same time, but it hits green first, so it chooses green, and then it goes up the tree and it hits blue and yellow, but it resolves that from left to right, so it chooses blue, so it gets the ID primary color blue. The third example is, I wrote that before putting it into the quick start, so already covered that. The fourth one, I wanted to go deep into an object, so I've created 4 levels deep here, and the last one, I wanted to prove that a class can contain a class, and then just have a look at the results of that. That's everything covered that I wanted to cover. I hope you find this tool helpful.